Thanks for joining me. I'm going to go through the 7th hour Math of Chemical Formula quiz. Now, after I go through this, feel free to watch the video on the 1st hour quiz and the 3rd hour quiz and see how you do on those quizzes if you want for some additional practice. So let's get started right away. Now, I've added the blue line on there. That's information you probably should know as you work through this. So this problem says, determine the approximate molar mass of this particular material, calcium acetate. So in the formula Ca parentheses C2H3O2, 2, there is one calcium using the periodic table that weighs 40 grams per mole. 1 times 40 is 40 grams. The 2 on the outside says there's 2 of everything in the parentheses. So that must mean there are 4 carbons. They each weigh 12 grams per mole from the periodic table. 4 times 12 is 48. 2 on the outside times 3 on the inside. There are 6 hydrogens. They each weigh 1 gram per mole. And there's 2 oxygen on the inside times 2. 4 oxygen times 16 grams is 64 grams. That means this entire thing, when you add it up, weighs 158 grams. That is the answer to the approximate molar mass for that first one. It'll take us probably about another 15 minutes or so to get through this, but hopefully, if you stay with me, it'll help you understand this a little bit better. We want to calculate the percent by mass of nitrogen in nitric acid. Well, in HNO3, we know the percent is the part divided by the whole, then times 100. So we have to figure out what the whole weighs. There's 1 hydrogen, it weighs 1 gram. There's 1 nitrogen, it weighs 14 grams. And there are 3 oxygens that each weigh 16 grams. So that's 48 grams. You add that up, the total is 63 grams. But the question says, what is the percent nitrogen? So the percent nitrogen is the part that's nitrogen, right there. 14 grams divided by the whole of 63 grams times 100, add your percent sign, and that will equal 22.2% nitrogen. All right, 2 down, 6 to go. We want to know how many molecules of fluorine are in 4 liters of this particular gas. So we know that 1 mole of anything, like fluorine, is going to be equal to 6.02 times 10 to the 23rd molecules of that material. Now, I don't need to know what it weighs. F weighs 19 grams, so F2 weighs 38 grams. Not needed for this question, and it would occupy a volume of 22.4 liters under these conditions because it is at standard temperature and pressure, STP. So let's write out the question. The question is, how many molecules of fluorine are there in 4 liters of fluorine? Now, that has 3 significant figures in 4.00 liters, so my final answer should have 3 significant figures. So I'm looking for a conversion between liters and molecules, and I have it right here. Every 22.4 liters is 6.02 times 10 to the 23rd molecules. I want to set it up so liters cancel, so it belongs in the denominator. 22.4 liters of fluorine is 6.02 times 10 to the 23rd molecules of fluorine. Liters of fluorine cancel. At this point, it's just a matter of typing in your calculator, knowing how to use your exponent key. Take 4 times Avogadro's number, hit equal, divided by 22.4, rounded to 3 significant figures. How about 1.08 times 10 to the 23rd molecules of fluorine? All right, we have now got 3 questions done. We have 5 to go. We've taken 5 minutes so far, doing good. Let's try this. Calculate the mass in grams of a sample that has this number of molecules of water. So we know that 1 mole of water is equal to 6.02 times 10 to the 23rd molecules of water. And because it's asking us about mass, I need to figure out the molar mass. Well, water, H2O, has 2 hydrogens that each weigh 1 gram. 2 times 1 is 2. And it has 1 oxygen that weighs 16 grams. So water weighs 18 grams. Now, water is not a gas at room temperature, so that doesn't apply. So the question says, calculate the mass of water that is equal to 1.85 times 10 to the 34th molecules of water. So I'm looking for a conversion between molecules and grams. 18 grams is an Avogadro number of molecules. So I'm going to go ahead and put that in. I know that every 6.02 times 10 to the 23rd molecules of water is equal to 18 grams of water. Molecules of water cancel like that. Carefully typing that into your calculator using the exponent key properly. 1.85 times 10 to the 34th times 18, hit equal, divide by 6.02 times 10 to the 23rd, and you should get the number on the bottom of the page. We have 3 sig figs in our problem, so we report it as 3 when we're done. 5.53 times 10 to the 11th grams of water. Boy, that's a lot of water. It's a lot of water. All right, we're halfway done. We got about 7 minutes on the clock done. We're doing very good on time. Next, let's find the percent composition of this particular compound. It says it's made of sodium and oxygen, and it has 53 grams of sodium, and it has 37 grams of oxygen. So the whole thing must weigh 90 grams. Well, the percent that is sodium is the part that's sodium, 53 grams, divided by the whole, 90 grams, times 100, add a percent. That is 59% sodium. Therefore, the remainder, 41%, has to be oxygen, because 100 minus 59% is 41%. If we didn't see that, we could have said percent oxygen is 37 grams, the part that's oxygen, divided by the whole, 90 grams, times 100, and we certainly would have gotten 41% oxygen. All right, halfway done, and we got only a third of our time used. We're doing good. Next, what is the molecular formula of paradichlorobenzene, an ingredient found in mothballs? Now, we're told that the molar mass is 147, and it has an empirical formula given. Now, I know, or I should know, that the molecular formula is related to the empirical formula by some whole number. You multiply it by 1, 2, 3, 4, some whole number. It could be the same. So I would start by figuring out, what does C3ClH2 weigh? So the formula says I have 3 carbons. They each weigh 12 grams. That's 36 grams. I have 1 chlorine. It weighs about 35.5 grams. Chlorine is one of the few atoms that I round to a half. And there are 2 hydrogens. They each weigh 1 gram. So the molar mass of this is 73.5 grams. Now, the key to the problem is the molar mass says it needs to weigh 147. So I need to figure out how many times does 73.5 go into 147. And the answer is it goes in 2 times. That means I need something that is 2 times bigger than C3Cl H2. And the way I'm going to write that is right down here. C6Cl2H4. That is the molecular formula for paradichlorobenzene or mothballs. All right, we've got 6 done, 2 to go. In an experiment, 5 grams of tungsten reacts with air to give 6.31 grams of tungsten oxide. From the name, hopefully you can tell tungsten, symbol W, and oxide, O, the only 2 elements in this compound are tungsten and oxygen. And so that weighs, as I've shown here, 6.31 grams, the tungsten plus the oxygen. And remember, we started with 5 grams of tungsten. So if you take 6.31 grams minus 5 grams of tungsten, you find out that you have 1.31 grams of oxygen. This is the thought process you need to go through to begin with. Now, it says we have 1.31 grams of oxygen and 5.00 grams of tungsten. So we didn't have to worry about step 1. We've already got grams. So now we're on to step 2, grams to moles. Oxygen, by now I bet you know, 16 grams of oxygen is 1 mole. 1.31 divided by 16 is 0.08188 moles of oxygen. Tungsten takes you a little while to find that one on the periodic table. It weighs 184 grams per 1 mole. Tungsten, it can be found, it's the heating element in your toaster, or it's the filament in a light bulb. And so if you do the math there, grams cancel, you're left with 0.0272 moles of tungsten. We just did step 2, got everything into moles. And finally, step 3 says divide by the smaller number. In this case, divide both by 0.0272 moles, 0.0272 moles, and at the top, you end up getting the number 3 oxygens. Down here, you get 1 tungsten. Putting this together, you get 1 tungsten and 3 oxygens. So let's go WO3. That's our answer for that one. Only have 1 to go. I said we'd try to get this done in 15 minutes. Let's see if we can. We got about 2 minutes to get it done. What is the empirical formula given that the molecular formula is this and has a molecular weight of here? Now, if you remember, the empirical formula is the lowest ratio. So C8H16 will easily reduce, if you divide them each by 8, to CH2. So CH2 is the empirical formula, and C8H16 is the molecular formula. So our answer is CH2. As simple as that. All right. What I'd like you to do, if you did not do maybe as well as you wanted on this one, you've now seen your version from 7th hour. Go back and watch the video from the quiz on 1st hour as well as 3rd hour. The questions are a little bit different in each hour, and I think there's something to be learned by reviewing those problems. The test was only worth 8 points. In terms of the entire second semester, you know, even if you get a 4 out of 8, it was only 4 points you're missing. So don't beat yourself up on that. Learn from your mistakes, and you're going to do just fine. All right. Thanks for keeping up and trying to better yourself. Have a great day, everyone. Bye-bye.